Recorded Books presents The Primacy of Doubt, From Quantum Physics to Climate Change, How the Science of Uncertainty Can Help Us Understand Our Chaotic World, by Tim Palmer. Narrated by the author.
To Jill, Sam, Greg and Brendan, for their love, support, patience and understanding. In memory of Dennis Sharma, Raymond Hyde, Ed Lawrence and Bob May, who in their own different ways taught and inspired me. Our freedom to doubt was born of a struggle against authority in the early days of science. It was a very deep and strong struggle. Permit us to question, to doubt, that's all, not to be sure. Richard Feynman. He believed in the primacy of doubt, not as a blemish on our ability to know, but as the essence of knowing. From James Glick's biography of Richard Feynman. In this audiobook, I will refer to some of the illustrations in the printed version. I hope I describe them well enough that you do not need to see the illustrations. However, in case you wish to view them, all the illustrations can be found on my website, www.primacyofdoubt.com. Primacy of Doubt written as one word. Thank you. Author's Note. As a reader, I suppose it's not unusual to skip over the preface to a book and get straight down to the business end of things. At least that's what I tend to do. If you do the same, it won't stop you understanding the key theme of this book, how the science of uncertainty can help us make sense of our very uncertain and unpredictable world. But you may wonder, since pretty much everything in life is uncertain, why I focus on the particular, seemingly disparate topics singled out in this book: climate change, economics, quantum physics and cosmology, human creativity and consciousness, to name a few. Why not earthquakes, drug design, or cyber attacks? The answer lies in my scientific background. I studied for a PhD in the 1970s, researching Einstein's theory of general relativity. Einstein had become a hero of mine by the time I was a teenager. I was lucky. The 1970s are considered to have been a golden age for general relativity theory. At the first scientific conference I ever attended, in 1974, I literally heard Stephen Hawking, he hadn't then lost his voice, announce his most important and famous result, that black holes aren't truly black, but radiate quantum particles. My research supervisor, Dennis Sharma, Hawking's PhD supervisor some years earlier, was ecstatic about this result. Sharma was optimistic that we were on the verge of understanding how to unify Einstein's theory of general relativity with quantum mechanics, the theory that successfully describes atoms and elementary particles. There were problems, however. One problem which frustrated Sharma was that Hawking's calculations were a little arcane. Sharma was convinced that there must be a more physically transparent way of deriving such an important result. He started to look at alternative ideas based on concepts from a field of physics called non-equilibrium thermodynamics. Sharma asked me to look at what is called the principle of maximum entropy production, something I hadn't heard of at the time. Towards the end of my PhD research, I'd become an expert on black holes and was successful in securing a postdoctoral position in Hawking's group at Cambridge. All seemed set for a career as a theoretical, gravitational physicist. But the closer I came to starting this new position, the less sure I became that this was what I wanted to do. For a start, the work I was doing had absolutely no relevance to the well-being of the person in the street. On top of that, I realized that there were actually only a handful of professional people in the world who were truly interested in the nitty-gritty details of my work. Perhaps none of this would have mattered if I felt I was going to be the person to unify quantum mechanics.
Sample complete. Ready to continue?